Good morning and good afternoon, depending on where you are, and welcome to this conversation on analytics and big data. We're talking about how analytics can help us optimize mobile networks today. They're under a lot of strain due to the increase in demand. So we need to make sure we get the most out of them, and analytics is the perfect tool for doing that. And this conversation is part of a report by Sensafili in collaboration with Arcer Wireless News. And today with me, I have Anssi Tauriainen, and he is the Director of Service Assurance and Analytics at EXFO. Anssi, thank you for being with us today.
Thank you, Monica. It's my pleasure.
So now EXFO has a huge amount, many solutions and services, and analytics is becoming a big part of what you guys do. Can you tell us what is that you're focusing on at EXFO on analytics specifically?
Yeah, certainly. So that is a big topic for us and a very important strategic project. So as you might know, EXFO has been in the industry for 30 years, so quite a while now. And the company is probably better known still for test and measurement solutions. So the background of the company is in fiber optics, where we started 30 years ago. Now, over the past 10 years, we have been expanding the solution offering more into service assurance space. So in addition to test and measurement equipment, we also have fiber network monitoring solution. We have active and passive probing solutions for different layers of the network. And we're actually using now the analytics solution to basically combine and correlate all of that data that we're basically collecting today from the operator's network. So basically we use it as for two purposes, for consolidating the data and correlating it between the domains, and then more importantly, making sense out of the data. So using then different kind of mechanisms to process that massive amount of data and make conclusions out of it.
Yeah, so we're going to talk about later about the specific of the solution and how does that work. But first of all, what motivated you to get into this, to work more on analytics? What is it you're hearing from the market?
Well, obviously there are major big transformations going on in telecoms industry. I think it's fair to say that there is some kind of transformation ongoing in telecoms all the time, right? For past almost 100 years. So now the latest trends are going, of course, we are seeing the amount of connected devices increasing all the time. So we see IoT coming, we see connected cars and that kind of new devices being connected to the network. We see networks being modernized. So for example, fiber to the home, fiber to the antenna projects are ongoing to basically to increase the capacity of the networks. 5G rollouts are already in a starting. And one of the biggest areas is network virtualization, where basically the existing legacy hardware-based architecture is being modernized and moved into cloud and moved as virtualized software. So our customers are basically planning this transition right now, and we get a lot of requests and inquiries in especially how analytics can be applied in a hybrid environment and in a virtualized networks, and how analytics can support in all of these transitions, basically in understanding the increasing complexity of the network and the infrastructure.
Yeah, and as I said, I guess that a lot of interest that you have from operators comes from the increased complexity. They have a network that is becoming virtualized, but not as fully virtualized yet. There's a lot of legacy. So there is a lot of complexity that you have to deal with. And so the traditional approach of optimizing the performance of each element is no longer sufficient, and you need to look at the end-to-end performance of the network. And you've been pioneering this approach for quite some time. Can you tell us a little bit about why do we need end-to-end, and first of all, what does end-to-end mean, and why is it important?
Well, You're absolutely right. We have been pioneering this, and we've been collecting requirements and implementing a solution already quite some time. Now, how we see the challenge today is basically there's a number of OSS systems or network management or element management systems for various types of networks, right? So when we started with in telecoms, when the rollout started, there was only a single network technology, mainly GSM. And after that, there has been layers and layers of new technology being implemented on top of that. And basically every time new technology gets implemented, a new OSS or new management system is implemented as well for that particular technology. So as a result, then the network operations, or nowadays the service operations, is fragmented. So it is not uncommon to see that, for example, network engineering people or technicians have to access tens of different systems in order to understand or troubleshoot problems in the network. So
yeah.
what we are trying to do, we're trying to simplify this by having a single system combining the data end to end. So not only focusing on a certain part of radio of the network, like for example radio network or core part or core network or transmission or optical network. Instead, we're building a solution that is able to combine all of it together. So that, let me give you a simple example. When you're troubleshooting, for example, what goes on with the voice over LTE call, you actually have a single system that contains the performance of individual networks for that particular call in a single system. So that basically saves time for manual troubleshooting, of course, because you can see a single call in a single system, but that also gives the basis to apply more automated mechanisms for troubleshooting and discovering the failures.
So this is interesting because you have a single solution. So horizontally, it works across different technologies. So it could be GSM, 3G, 4G, and eventually 5G, different networks. And then on a sort of vertical level, all the way from the core to the RAN. Is that right? So it's a unique point where the operator can have the whole optimize the whole network.
Absolutely, and there is even one more dimension to it. So if you think about the network as layers of different network technologies, if you think of the traditional OSI model, there are actually 7 layers on top of each other. And in order for troubleshoot and understand how network is performing, you actually need to understand the performance of different layers because they are connected to each other. So if we take, for example, the previous example, the previous operating example for voice over LTE, in order to understand why subscribers voice over LTE call the services degraded, it is actually extremely useful to have the ability to drill down to lower layers of network. For example, layer 3 on analyzing how the IP network is performing. And for example, connect this information that there's for example a path in a certain path in a network where the network latency is increasing. Connect this information back to the subscribers and understand that this is the reason why the service is degrading. But there's also another, even you can go really even one level lower, right, to the layer 1 to analyze the performance of the fiber network and understand that there's, for example, increased signal loss on a certain part of the fiber network, which is in turn causing the increased packet loss or latency on a certain part of the IP network. So this is what we mean by the end-to-end, that you can't actually just analyze the data from a single layer and expect to troubleshoot it either manually fast or implement an automated mechanism to troubleshoot without actually having the visibility across all of the layers.
Right. So basically, you see that something either needs to be optimized or it's not working properly, and then you can dig down in whichever dimension is more appropriate, right?
Absolutely, and using the single system, right? So,
yeah.
So not having to jump from different one system to another.
Yeah, and I guess that if I might add, there is yet another more dimension, which is the different applications. Which so if you say you have VoLTE and you have VoLTE video and best efforts data, you can do the same analysis for each service, so that an operator could say, well, best effort data works perfectly fine, yet we have a problem with video or with conversational video or whatever. So it helps them not just to look at the overall network performance, but what is the performance for different services, right?
Absolutely. So the end users, whether those are business users or subscribers, they don't make a difference between the services. For them, it's the one provider providing everything, right? And they expect all of them to work flawlessly at the same time.
Yeah, yeah. And I guess here the scope is from an operator is to optimize quality of experience rather than making sure that one element, that something is working correctly. It's the end result is the QoE. So you need to have this kind of a high level view of what's going on and how to optimize this, all the applications together. You cannot just, I guess you cannot just optimize one application and hope for the rest to work well.
No, not really. I think that was the kind of the idea with the network management systems and OSS systems earlier. That if you manage individual elements and their fault situation is good enough and the performance is good enough, then everything else on top of it is working well enough. And that was the principle back in the days. Nowadays that has shifted, a major shift from the network-oriented operations into service operations has taken place, and you're absolutely right. So the focus is actually on the quality of experience for individual services and how that is impacting then what is the impact on end users or either subscribers or business services. So right now there is a certain amount of services that are being used, but the expectation is that there will be even a large amount of services in the future, and the operators are aiming to model where they are able to create new services in a very agile mode. So that of course puts another big challenge to analytic systems. So the analytic systems support the agile creation of new services.
Mm-hmm. And among the services clearly is IoT. How is that going to affect analytics?
Well, obviously, you can always when you're analyzing this for end users, and now I'm talking about human end users. There's always the human behavior, which is more difficult to model. So you don't actually you need to have several data points in order to model and understand what is the experience satisfaction level of your customers. Now in IoT, that's of course going to change because the machines don't have their opinion on the service quality simply based on KPIs, right? So in a sense, it's going to make it a bit easier because you can base the analysis purely on hard facts. But of course, the volumes are going to be substantially increasing, and that's going to set two challenges. First of all, there's a large amount of data to be processed, and the second thing, the real-time aspect. So it has to be more real-time, and technologies such as streaming analytics need to be taken into use in order to react to different things, different phenomena in the network in few seconds.
Yeah. And you mentioned real time. That's a big change as well. We used to do everything sort of you optimize network based on historical data, and the time frame there it's really slow. That's not sufficient anymore. Still important, but not sufficient. And so we need to move to real time, but operators are also a little bit worried because as you do things in real time, things happen faster than, you kind of feel like you're losing control. You want to make sure you have it right. How do you deal with doing analytics in real time?
Well, the real time is an important aspect, and I think that's right now, if we look at the analytics, most of the analytics solutions are mostly in reactive mode, right? So when something happens in the network, it needs to be discovered fast and the correction needs to be implemented fast. So two important drivers or two important KPIs to measure this are mean time to discover, MTTD, and mean time to repair, MTTR. So basically, understanding what's going on in the network and understanding how to fix it are two key drivers. And of course, the shorter and easier the troubleshooting and discovery and troubleshooting and fixing is, then the greater the benefit the analytics solution brings, right? So this discovery can be either manual or like our goal is that we want, for example, the root cause analysis to be fully automated when it can be actually done much faster than with the traditional manual methods.
Yeah.
So in that sense, the real-time aspect is very important because you want to react to this. Once you have the capability to do automated troubleshooting, you want to do it as soon as something happens in the network. Now, in the future, I think one of the big changes in the industry and in analytics is the usage of artificial intelligence. So there's a number of success cases already in other industries how artificial intelligence or machine learning is being utilized to actually solve complex problems. Watson is a good example. IBM is publishing a number of use cases they managed to sort out by using Watson. So that same new technology can be applied and is being applied in telecoms as well. So what today is reactive and based on very much on discovering things in real time is going to be even further automated. So moving from real time into predictive and finally into cognitive analytics. So predictive and self-learning analytics methods can actually tell you what's going to happen next, instead of just, in addition to telling you what's happening right now and how to fix it, also indicating what's going to happen next.
Yeah, and I guess that's really the real target. You want to prevent a problem from arising in the first place. How important do you think that tools like artificial intelligence and machine learning are going to be in this context?
Well, of course, it's never going to be fully automated, and it's never going to be fully predictive, right? There are certain things you simply can't predict, even regardless of how advanced your algorithms are. But if you look at the operational cost today, how much operators are spending money in operating the network, and how much of that work is based on manual analysis and knowledge that is residing in the skilled engineer's head, that's actually a very, very big number. So and one of the main mechanisms to reduce this is actually introduction of artificial intelligence and self-learning or machine learning into this domain.
Mm-hmm. Yeah. Can you tell us a bit about the acquisition of Ontology? That was really brought a lot of the analytics, new analytics stuff into EXFO. Can you tell us more about it?
Yes. So Ontology is basically, they have developed technology that enables them to build a dynamic topology of the network. So they have a solution, or nowadays we have a solution that connects different data sources from the network. For example, inventory data, event data, billing, customer information, and this disconnected data can be, and unstructured data can be processed, and basically a dynamic topology model of the network can be created out of this. So basically the inventory systems today, even in physical networks, the inventory systems are very laborious and expensive to keep up to date, and often as a result they are mostly out of date. But with the dynamic discovery of the topology, then it actually enables us to have up-to-date real-time topological map of the network, which is a great basis for applying then further analytics. So it itself can be used already for understanding for example, the service impact, or it can be used for troubleshooting. But when we are connecting this into various, for example, probing solutions or analytic solutions that EXFO today has in their portfolio, we can actually build more advanced solutions. So Ontology is a key piece, for example, in automating the root cause analysis for different kind of networks.
Yeah, and I guess this is very useful in terms of dealing with the amount of data an operator typically has. So an operator knows everything about the network if they want to figure it out. But the question is how to organize that knowledge and how to find what's relevant and what's not, because most of the information is not relevant, it's not needed, but you need that small amount that it's correct, that it's relevant to address or to find causes or to address them.
That's right. And this is and you have to remember that this is the situation even today when most of the networks are physical, based on physical hardware. So in virtual environment, when everything is running, or most of the functions are running in the cloud, it's going to be more dynamic. And there's a period, there's going to be probably 10 or 20 years when we're still going to have hybrid networks, which are partially based on dedicated hardware and partially cloud-based. And having up-to-date information on what is the configuration and topology of the network is going to be essential in understanding how the network performs and how it can be optimized.
So you mentioned virtualization, and clearly that is going to change the way we optimize the networks, especially as we have both virtualized networks, partly virtualized networks, and legacy networks together. How is that impacting the analytics and where we optimize networks?
Well, obviously there's a big change coming, because in fully virtualized environment, there is actually an opportunity component, a key component called orchestrator is capable of managing and configuring the network on a fly, changing the network configuration and capacity based on the performance of and experience of the services provided. Now, before going into that, there's a more simpler need for analytics, and that's basically managing the hybrid networks. So combination of virtualized networks and physical hardware. In that kind of networks, the key use case is understanding how the new virtual components perform, and combine that information with service experience data, basically to understand how to optimize the cloud service in connection to hardware components in order to improve the overall experience to end users. Now, moving into fully virtualized environment, there is a use case which I think is generally called closed loop analytics, where the idea is that there's a component that basically is feeding the information to orchestrator, and that component is analytics. That's kind of the brain of the NFV. So understanding of the performance of the network and understanding of the performance of virtual functions, and then creating recommendations based on that, and then feeding that information to orchestrator, who then goes ahead and executes the change. So this is probably a few years away from now, because there are no such thing as fully virtualized environments today. But I think that's a very clear difference we see in the market today already.
And thanks, Anssi. That was a great conversation on analytics, how it is today, and what's going to happen in the future. And again, this was a part of a report on analytics, big data, and tools like AI and machine learning that are used to improve the way we optimize networks. It's a report by Sense of Feeling, collaboration with RCR Wireless News. And thank you all for listening in.